This is an extra video on data visualization. So we've looked at visualizing two variables. We've looked at visualizing one variable. What if we have more than two variables and we want to compare three different variables or more together? So we've seen bar charts before, and you might have seen something like this before. We can color code our bar chart or cluster our bar charts together using a key in order to represent more dimensions. So here we have three variables. This is data from the Titanic. We have the y-axis is number of survivors, that's our ratio data. The x-axis is the class they were in, first class, second class and third class cabins. And now the colour, we've coloured them according to gender. And this is about the extent we can do with adding variables. We couldn't add a fourth variable into here. Where would we put it for a start? And it would be really difficult to read even if we could. So 3 is about the extent. I would never recommend more than 3. So this is called a clustered bar chart. You may see something called a stacked bar chart, where you have a bar chart but the two different categories are sort of stacked one on top of the other. They are, don't get me started on them, they are bad. Don't do them, they are really misleading. They are like pie charts, right? So if you are going to represent a third variable, cluster them like this and color code them. If you're doing a scatter plot and we want to introduce a third variable, we can add another color. So here I've got various cities in the USA and Canada. So I've got the x-axis is population, the y-axis is net emissions, and I've used colour to distinguish between the USA and Canada. Why have I done this? Well, the USA and Canada might have different trends because those trends might not all be clumped together. There might be different trends for different countries. A really important thing to note here is that as well as using colour, I've also changed the shape of the marker. So I've used circles for Canada and X's for the USA. That is for colourblind people. If people are colourblind, this is going to be a little easier to read. It'll be won't be able to read it if you're just relying on colour. If you are going to separate by colour, try and have something else as well to distinguish it, and be very clear, like in the key here, be very clear what those represent. If you're doing a scatter plot and your third variable is a ratio variable and not nominal or ordinal, then you could actually use a colour bar. So here the darker colours represent low numbers of population and the lighter colours represent high numbers of population. If you're going to use a colour bar, be careful the type of colour bar you use. This particular one, I've been assured by the software that I use to create this, is meant to be friendly for colourblind people. I'm not colourblind myself, so I wouldn't know that, but that's something you need to think about. If you are going to use colour bars, try to be as inclusive as possible in your graphs. Similarly, for line plots, you can add more than one line to represent different nominal or ordinal data as the third variable. But again, as well as introducing different colours, you can try and break up the line. So one line here is solid, one line is dashed, one line is dotted, and so on. I now want to give some examples of some really bad data visualizations and what can we learn from them. So I'm gonna go through a few examples. Here's one that was on a political website, which was talking about welfare funding in the US. And what they were trying to show with this was that welfare funding was increasing, and it looks like it's a dramatic increase. But worse than bad, it's misleading because it's omitting the baseline. Look at the y-axis there. We start off with 94 million and we go up to 108 million. They've omitted the baseline to try and deceive their audience, and that's really, really bad. So this graph was used on the internet, and it was used to try and show that global warming was a myth, because they were saying, here's the global temperature from 1880 to 2014 or wherever it was. Look, temperature hasn't changed at all. But that's because they were dealing with Kelvin. So Kelvin, they start off at 0 and they went all the way up to 280, 290. It's going to show nothing because the range of temperature on Earth is within about 10 degrees rather than within about 300 degrees. So this was another misleading graph because they included all the scale. And I wouldn't recommend cutting off the scale at all, because again, that's misleading. But what I would recommend here is, if you're dealing with temperature, but you have a different scale, you have Celsius instead of Kelvin, that you could have utilised here to really prove your point. But this ended up being deceiving. Another really bad thing you can do with data visualizations, and you can do this by accident sometimes, is omitting data. So here's a graph that appeared in, it was one of the elections, I've got the link there, it was one of the elections, and Labour Party showed this graph and said, no, this is a two-horse race, only the Labour can beat the Tories, whatever, right? I don't care about that. But what was interesting here is The Guardian found this, and The Guardian pointed out, actually, this was the previous election. Yeah, Labour, Tory and the Lib Dem, they were in that order, but they'd completely missed out all the votes that went to the Green Party, and it was a really close race between the Green Party and Labour. So obviously it was done here to be misleading, but you might not do this to be misleading. You might just think, oh, well, if I'm comparing McDonald's and Burger King, Subway's irrelevant, or you might accidentally miss out data or whatever, and not realise that the graph that comes out is going to be misleading. So you need to be careful that you don't omit data from your graph. Another thing that can be done to mislead the public, and this is a really terrible thing as well, is breaking conventions. Conventions are there for a reason, because people know how to read them. Okay, so if we look at this graph, this was a graph used to show numbers of gun deaths in Florida, and when Florida enacted a new law to do something, it was to let guns happen or something like that in 2005. And this data is trying to show that in 2005, after that gun law was put in, gun deaths plummeted. So it's like, yeah, when we let people have guns, there's less gun deaths. Whereas actually look closer at the y-axis, they've reversed the y-axis, and that's not done in graphs, right? We're all reading this initially, skimming it, thinking the y-axis starts at the bottom, because that's the convention. They've broken that convention to try and prove a point, and they're lying to us. Another thing you need to be careful of when you do visualization, within the same piece of work, and especially within the same data visualization, the same plot, you need to be consistent. There's no inconsistencies. So this graph cropped up the day after the Brexit vote in Britain. I don't care about the politics, but this really angered me, because this was used to show that Northern Ireland and Scotland voted fundamentally different to the rest of the UK, and they are such fundamentally different countries. Whereas look closely, this is what the actual graph looks like. Okay, the colours are inverted, blue means yellow, yellow means blue. Don't worry about that, but look at Northern Ireland and Scotland now. What's going on? For all of Great Britain, they split up and coloured by county, whereas for Northern Ireland, they coloured the whole country in, depending on who voted more. Whereas in the real data, when we split Northern Ireland up by county, you can see that actually some of them voted differently. So there was an inconsistency here, which you might not have picked up on, because those county lines are really subtle, right? You might not have picked up on, and that can mislead the reader. I mentioned before about if you've got more than about 3 variables on your plot, it becomes unreadable. Here's an example of this. What is this plot saying? It's completely unreadable. It's a bar chart, but it's also all the bars are split up. There's color coded. There's writing on it. I don't know how to read this, so it's completely unreadable. Keep your data visualizations to 2, and at the most, if you're pushing it, 3 variables on one plot, but 2 if you can. Sometimes when you're being a bit artistic with your plots, that might have some unintentional consequences. So read this tweet, this made me laugh. But this was meant to be a bar chart, and by using pictures of people instead of bars, we can see that, Latvian ladies look terrifying compared to Indian ladies, right? And obviously that's not true. But we've got something to learn from this graph. It's not don't be creative with your graphs, be as creative as you want with your graphs, right? I love a creative graph. But here, this was meant to be a bar chart. And if we look at all the bar charts we looked at before, height changed, width didn't. Okay, and why is that? It's because height represented the value, but if we keep width the same and just change the height, our mind also tells us we can interpret area of the bar as the value as well. The bigger the area, the bigger the value. If a bar has got twice the area of another bar, it's got twice the value of another bar. Whereas here, because they've used this little image of a lady, the more they made the lady taller, they were also making the lady wider because they wanted to keep the aspect ratio the same. And that was dangerous because, for example, South Africa and Latvia here, even though it's twice the height, well, it's not twice the height because the y-axis is misleading, but even if it was, right, even if that was twice the height, you're also twice the width. So your area, your surface area, is 4 times the size. So that's really misleading. They've also added colour in here for no reason at all. Is this colour coded? No, it's just so that they don't have overlapping of the same colour, which shows how silly it is, right? So there's a lot of things bad going on here, but one of the biggest ones there is by changing the height, they're also changing the surface area in a way that's not proportional to how the variable changes, and that's bad. This graph, I didn't even know, I've just put question mark, question mark, question mark. I didn't know how to describe this graph. What is going on? What is going on here? There are no axes. This is both a pie chart and a bar chart, and it's 3D. What are we meant to be comparing? So even if there was an axis, what are we comparing? Are we comparing angles here, like a pie chart? Are we comparing height here, like a bar chart? Or are we meant to be comparing the volume of these sort of segments? And that really shows how bad 3D charts are. Like if I see a 3D chart, throw it out the window, right? 3D charts are really bad because you can't, if you've got a 3D bar chart, if you're comparing the height, why is it 3D? And if you're comparing the volume, then that's really difficult to see in this sort of pseudo 3D, because it's not an actual 3D model, it's a 2D representation of a 3D model. So it's really hard to see. But if you're showing just height and not volume, then just do a bar chart. Like 3D charts are terrible, but here I don't know what I'm comparing. Am I comparing angles, height, or volume? And all 3 of those are showing different things. So I do not know. Finally, this is a graph that was submitted a lot more than you think, submitted a lot in last year's coursework. This is a bar chart of the ages of patients in a data set from a hospital. What's the x-axis? It's completely meaningless. Here the x-axis was just the patient ID number, which was just the row number they appeared in the data set. Okay, this means nothing, this shows nothing. Okay, make sure that if you're doing a data visualization, all your axes are meaningful, because this is showing nothing. Even worse, I did have some submissions which were this, which is exactly the same data, but now for some reason they've ordered the x-axis by age. So it looks like there's a trend, and actually this was submitted with a paragraph which explained how there was a trend that ages were increasing. And the thing they are reading from their graph is the very thing they did to the data themselves. So this was just completely meaningless. So I hope from those examples of bad data visualizations, you can pick up some tips on how to do good data visualizations. So keep to conventions. Your chart area, you should be comparing one thing. Compare height or area, but not both. Make sure you've got a sensible scale. Make sure you've got meaningful axes. Make sure that if you've got ratio data, you're always starting at 0. Make sure there's no inconsistencies in your different data points. Make sure it's readable. Stick to about, at the most 3, I advise 2 variables on your plot.